90% of a building's environmental impact comes from the energy used during its lifetime. You can reduce these impacts enormously by using only renewable sources like solar or wind power. But that might be cost prohibitive for a building that's not built for energy efficiency. It's always cheaper and more effective to reduce the amount of energy your building uses. In a commercial building, that energy demand might break down like this. When you generate enough energy on site to equal your annual energy needs, you've got a net zero energy building. Many regulators are deciding we need to build more of our buildings this way. To achieve net zero cost effectively, you'll need to reduce energy demand as much as you can. With passive design strategies, you use the energy that's already around, like the sun's heat and light. If you use passive strategies well enough, you can also save money by downsizing or even eliminating the need for big heating, air conditioning, and lighting equipment. And when you do need this equipment, smart design can make it ultra efficient. The first step is to understand the building energy demands, or loads. Let's start with external loads. The sun heats a building through its outer skin and windows, or envelope. The envelope can also gain or lose heat to outside air. But good design can turn these loads into energy assets. Instead of resisting these loads, you can use this natural energy to work for you and reduce the energy you need to generate. Buildings also have internal loads that need to be managed by cooling. Heat is generated inside a building by lighting and equipment. For example, an incandescent light converts 90% of its electricity directly to heat. And then there's heat and humidity from people. An adult at rest generates about 100 watts of heat, while someone exercising can generate over 500 watts. In a building full of people, that's a lot of heat energy. All this heat can add to your building's cooling load, or, if harnessed wisely, it can help you by reducing your heating load. There are other kinds of energy loads that come from the inside of a building too. Lighting loads and plug loads come from keeping the space illuminated and running equipment like computers. In densely populated buildings, internal loads tend to be much greater than external or envelope loads. In buildings without many people or machines, it's the opposite. In the next few chapters, we'll explore design strategies to work with these loads so you can reduce energy demands and get on the path to net zero.